Hello there, and welcome to this Sleepy Nature channel. There is something no one tells you about lightning. We grow up thinking of it as danger, the sharp crack, the split-second brightness, the reason to come inside and close the windows. But beneath every storm, in the quiet that follows the flash, something is happening that most people never hear about. Something ancient and generous and almost impossibly small. In the fraction of a second that lightning exists, it performs a kind of alchemy. It reaches into the very air around it, the same air you are breathing right now, and unlocks something that has been sealed inside it all along. A gift, one that plants have been waiting for since before there were forests. One that seeds lying in the dark soil have been relying on since before there were flowers. One that the earth itself, in its patient and unhurrying way, has come to count on every time the sky grows heavy and electric. Lightning does not only destroy, it feeds. And tonight, very slowly, we are going to follow a single bolt of lightning all the way from the charged and stormy sky, down through the falling rain, into the warm dark of the soil, where the worms are breathing and the seeds are dreaming and the roots are reaching quietly towards something they cannot name, but somehow already know is coming. Find somewhere comfortable. Let your body settle into whatever is holding you, and breathe slowly, without effort, as we begin. Close your eyes for just a moment and imagine the sky before a summer storm. The air feels thick and warm. The clouds have been gathering since midday, tall and slow-moving, soft at the edges but deep gray at the center. Birds have already found their places in the branches tucked close to the trunks. The leaves are still. Everything is waiting. The earth below is waiting too. The soil is layered and alive, dark on the surface, where old leaves have broken down into something soft and sweet-smelling, then paler, deeper down, then sandy, then clay. Each layer has its own quiet world. Fungi stretch their threads between particles of soil like the thinnest imaginable lace. Beetles rest in chambers they dug themselves. Seeds lie still, not sleeping exactly, but not yet awake either. Above all of this, in the atmosphere, something important is happening that most of us never think about. The air we breathe, this invisible sea we all move through, is nearly 80% nitrogen. Nitrogen is one of the most important things a plant can have. Without it, leaves cannot make chlorophyll. Without chlorophyll, there is no green. Without green, there is no growth. And yet, despite swimming in nitrogen constantly, plants cannot simply reach up and take it from the air. The nitrogen up there is locked. It travels in pairs, two nitrogen atoms holding each other so tightly that almost nothing can pull them apart. This is where lightning comes in, not as something frightening, but as a key. When a lightning bolt travels through the sky, it heats the air around it to temperatures almost 5 times hotter than the surface of the sun, just for a moment, just for the blink of a thought. But in that moment, that intense heat is enough to crack the bond between the two nitrogen atoms. They separate briefly like two hands letting go. In that brief separation, nitrogen atoms are free to combine with oxygen, which is also always present in the air. They form a compound called nitrogen oxide. And nitrogen oxide, unlike the original nitrogen gas, can dissolve in water. And rain, of course, is on its way. The storm arrives softly. You can hear it before you feel it, a shifting in the air, a distant sound like paper being gently crumpled. Then the first drops, cool and irregular, touching the leaves and the dry earth. Each raindrop, as it falls through the air, collects tiny traces of these nitrogen compounds. The rain is not just water, it is a gentle delivery system. By the time the rain reaches the ground, it carries within it a gift, a form of nitrogen that the soil can hold and that plants can actually use. It soaks through the surface, moves between the grains of earth, and begins to settle where roots wait. This is a process called nitrogen fixation. It happens all over the planet, continuously. Scientists estimate that lightning strikes the earth roughly 100 times every single second. Each of those strikes, in its own small way, is nudging a little more life into the soil. If you've ever noticed how green and vivid the world looks the day after a storm, that fresh, almost glowing quality the grass takes on, part of what you are seeing is this: the plants have received something they needed. They are, in their slow and rooted way, responding. The storm passes, the sky lightens, water collects in the curved cup of a leaf and trembles there like a small mirror. Somewhere below, in the dark warmth of the soil, roots are doing what roots do, reaching, sensing, drawing in. If you are comfortable with your breathing right now, let yourself take one slow, deep breath. And as you exhale, imagine you are releasing something you no longer need. The way nitrogen releases from its bond in the sky, soft, slow, and necessary. The rain has moved on now. The storm is just a memory in the air, a faint electric smell, a coolness on the skin. But underground, things are only just beginning. Let's follow a single raindrop as it disappears into the soil. It is a small drop, barely the size of the tip of a finger. It carries with it a trace of nitrate, which is what the nitrogen compound is called once it has fully dissolved. As the drop slides down between grains of sand and clay, it passes things that are extraordinary in their smallness. There are bacteria here, hundreds of millions of them in a teaspoon of healthy soil. They are among the oldest living things on Earth, and they have been doing their work in the dark long before there were forests or flowers or birds to sing in the morning. Some of these bacteria are specialists. They have spent billions of years learning how to work with nitrogen. They take the nitrate the rain delivers and turn it into the form plants can actually absorb through their roots. This is a relationship older than almost anything we can imagine. Plants and bacteria underground in a kind of silent agreement that has kept the world green. Meanwhile, above the surface, the trees are still dripping. Water runs down the bark in thin, winding paths, following grooves worn smooth by years of rain. At the base of an old oak, the water gathers and then disappears into the mat of moss that grows there, thick and soft as a cushion. Moss is very good at holding water. It is one of the quietest and most generous things in the forest. The moss, like every green plant, is hoping for nitrogen too. It takes what it can from the rain directly, absorbing nitrogen compounds right through its soft surface. It doesn't need roots for this. Moss is patient and resourceful in ways that are quite beautiful to think about. If you are reading or listening to this from somewhere cozy, a bed, a sofa, somewhere warm, you might take a moment just to feel the surface you're resting on. Something soft beneath you. Gravity, gentle and steady, the world holding you up, the way soil holds everything that grows. There is a place on the ocean floor where hydrothermal vents push hot, mineral-rich water up from deep inside the earth. Scientists who study these places have found entire ecosystems living there. Strange and beautiful creatures in the dark, eating not sunlight, but chemistry itself. They survive on the minerals that rise from below. This is interesting to think about in relation to lightning, because it reminds us that life is endlessly creative about where it finds its food. Life does not wait for perfect conditions. Life finds a way to use what is available, even the electricity in a storm. But we don't need to go to the ocean floor to see this creativity. We can find it right here, in an ordinary meadow after rain. In the weeks following a thunderstorm, researchers have measured increased growth in grasses and clovers. The growth is subtle, not dramatic. This is not some sudden explosion of green. It is more like a quiet brightening. Grass that was a little pale and reaching becomes fuller, more itself. The nitrogen from the storm has moved through the soil and found its way into roots. Clover is especially interesting here. Clover belongs to a family of plants called legumes, and legumes have a special relationship with certain bacteria that live in nodules, little round bumps, on their roots. These bacteria can fix nitrogen directly from the soil atmosphere without needing lightning to crack it open first. They are doing their own version of what the storm does, quietly, all year round. When you walk through a meadow and feel the grass brushing against your ankles, some of what you are feeling is this long, slow process of nitrogen being passed from the sky to the rain, to the soil, to the bacteria, to the roots, to the stems, to the leaves. You are walking through a system that has been running continuously and without any help from us for hundreds of millions of years. There is something deeply restful about that thought. The world knows how to take care of itself. And if you are enjoying tonight's story, there is a playlist of other gentle nature stories waiting for you. Just check the description or the channel. Each one is made for moments exactly like this one. Let's slow down even further and spend some time with the worms. Earthworms are not glamorous creatures. They don't have songs written about them. They don't appear in nature documentaries very often, and when they do, it is usually only briefly from a distance. But if you were to ask a gardener or a farmer or a soil scientist what a truly healthy piece of earth looks like, they would talk about worms before almost anything else. A single acre of healthy farmland can contain more than 1 million earthworms. 1 million. Moving slowly through the dark, eating, casting, breathing, aerating. Their tunnels let air and water move through the soil more easily. Their castings, which is the gentle word for their waste, are rich in nutrients, including nitrogen compounds. When lightning-fixed nitrogen arrives in the soil, it doesn't stay still, it moves. Water carries it sideways and downward. Worms interact with it as they eat the organic material around it. Fungi thread it from place to place. The soil is not a container, it is a network, a conversation happening in slow motion below our feet at all times. After a rain, you might have noticed that earthworms come to the surface. There are a few theories about why. Some scientists think they use the wet conditions to travel longer distances than they could underground. Some think they are responding to vibrations from the rain. Whatever the reason, you will often find them on pavements and paths after a storm, pink, gentle, a little dazed looking in the light. If you have ever gently moved a worm from concrete back to a patch of grass or soil, you have already done something kind for the earth's chemistry. You have returned a small part of the soil's infrastructure to where it belongs. Outside right now, wherever you are, the soil is doing its slow and important work. Even under cities, even under roads, wherever there is a patch of earth, the chemistry continues. Now let us think about seeds. A seed is a remarkable thing. It is a whole plant, compressed and patient, wrapped in a coat that can survive cold and drought and the passage of years. Some seeds are so small you could hold 1,000 of them in your palm. Others are large and heavy, like the coconut, which can travel across oceans and begin growing on a distant shore. Seeds are waiting for the right conditions: warmth, moisture, the right balance of minerals in the soil around them, and, yes, nitrogen. When lightning-fixed nitrogen makes its way into the soil after a storm, it can reach seeds that have been sleeping for a very long time. It doesn't wake them all at once. Seeds are not so simple as that, but it can shift the balance of nutrients around them just enough to tip things toward growth. There is something called a seed bank, not a financial institution, but a natural one. In any healthy patch of earth, there are seeds from dozens of different plants lying in the soil, waiting. Some of them have been there for just a season. Others have been waiting for years, or even decades. Scientists have germinated seeds found in lake sediments that were hundreds of years old. The soil remembers. It holds possibilities in reserve. When rain follows a thunderstorm and nitrogen-rich water moves through the earth, it is like a message being sent through that underground archive. Not all seeds respond, but some do, and the ones that do begin the tiniest, slowest possible movement. The radical, which is the seed's first root, pressing outward with a force far greater than you would expect from something so small. This is one of the quietest things in nature. A seed sending out its first root is making no sound at all. It is a thing that happens in complete silence, in the dark. And yet, it is also one of the most hopeful things in the world. Let's take a moment to appreciate the sound of rain on leaves. It is one of those sounds that the brain tends to find peaceful, perhaps because we have been hearing it as a species for as long as we have existed. Rain on a broad leaf makes a soft, irregular tapping. Rain on grass makes almost no sound at all, just a gentle shh, continuous and blurring at the edges. Rain on the surface of a still pond creates small craters of water that collapse immediately and send out tiny rings. Each one of those drops, as it falls, is part of this great nitrogen delivery. A storm that covers 100 square kilometers might deposit enough nitrogen to measurably change the chemistry of every lake, forest, and meadow beneath it. And here is something that might surprise you. The nitrogen that lightning fixes is not just important to the plants it lands near. It eventually works its way into everything. Plants absorb it. Insects eat the plants. Birds eat the insects. Animals eat the plants too, and other animals. The nitrogen that was once locked in the air above a field in Norway, or a forest in Brazil, or a meadow in New Zealand, eventually travels through the whole food chain, becoming part of feathers and fur and bark and pollen. You yourself are made partly of nitrogen. The proteins in every cell of your body contain it. Somewhere in the long history of the atoms that make up your hands right now, there is almost certainly nitrogen that was once fixed by a bolt of lightning, perhaps thousands of years ago. This is not a strange or frightening thought. It is, when you sit with it, a rather beautiful one. You are part of this same long chemistry. You and the grass and the worms and the birds in the morning are all made of the same recycled elements, passed from one living thing to the next, shaped and reshaped through time. We are all, in some very real sense, made of old weather. If you have found this story restful so far, please do consider leaving a like. It helps others find their way here to this quiet corner of the channel. And we are only halfway through our journey tonight. Let's move to a pine forest, somewhere cool and northern. The trees here are tall and dark-needled, their branches dropping slightly under the memory of past snowfalls. The forest floor is soft and rust-colored, layers of fallen needles built up over decades into a cushion that gives a little under your foot. It smells of resin and cold earth. Somewhere nearby, a small stream moves between mossy rocks. Pine forests are interesting in terms of nitrogen because they are, in many ways, nutrient-poor environments. Pine needles take a long time to break down compared to the leaves of oak or maple or beech. The soil beneath a pine forest tends to be more acidic, and more acid soils can make it harder for nitrogen-fixing bacteria to do their work. And yet, pine forests grow. Tall and steady and deeply rooted, they manage partly because of fungi. Pine trees have an ancient and intimate relationship with mycorrhizal fungi, fungi that weave their threads between the soil particles and also directly into the tree's root cells. The tree gives the fungi sugars made from sunlight. The fungi give the tree minerals and water gathered from a much wider area of soil than the roots alone could reach. When lightning-fixed nitrogen enters the soil of a pine forest, it is the fungi that help spread it. Fungal networks can extend for meters in every direction from a single tree. They are sometimes called the wood wide web, which is a lovely name, although the reality is quieter and slower than that phrase might suggest. Imagine a root system extended 10 or 20 times in all directions by these soft, invisible threads. Nitrogen absorbed on one side of a fungal network might eventually reach a tree that is several meters away. In this way, the gift of a single lightning strike can spread through a forest slowly, like warmth spreading through a room. The pine forest doesn't know this is happening. The fungi don't know it in any way we would recognize as knowing. It simply happens as it has always happened, without language or intention. And the trees grow. The relationship between lightning and life goes back much further than pine forests, or meadows, or even the first flowers. For the first billion years or so of Earth's history, there were no plants, no insects, no animals of any kind. The early Earth was a world of bare rock and shallow ocean, and the only living things were microbial, single-celled organisms doing chemistry in the dark and in the shallows. Even then, lightning was fixing nitrogen. Even then, that nitrogen was dissolving in rain and ocean water and feeding those first, simplest creatures. Scientists who study the origin of life have found something particularly interesting. Some of the amino acids, the basic building blocks of proteins and life itself, can be formed when lightning passes through a mixture of gases similar to early Earth's atmosphere. In laboratory experiments, when they pass electricity through these gases and add water, they find organic molecules forming, including some of the same amino acids that make up every protein in your body. Lightning, in a sense, may have been one of the first great chemists. It may have helped cook the first ingredients from which life eventually assembled itself billions of years ago in a warm, shallow pool somewhere on the young Earth. This is not something that keeps most people awake at night thinking about it. But it is, quietly, one of the most extraordinary things about the world, that the same process that makes the sky flash during a summer storm also, in some deep and indirect way, connects back to the very beginning of life itself. You are lying somewhere comfortable right now, breathing slowly, and you are connected by chemistry, by time, by the same atoms cycling endlessly, to the first spark that ever ignited in a prehistoric sky. That is a long and peaceful thought to rest in. After the storm, there is always a particular quality to the morning light. If you have ever woken up after a night of heavy rain to find the world washed and still, you will know what we mean. The air has a clarity to it. Colors are a little more saturated. The green of the grass slightly deeper, the gray of wet stone almost silver. There are birds beginning their work in the early light, moving through the wet branches, shaking drops of water from the leaves as they go. The soil is still absorbing. Nitrogen is still moving through the layers. Seeds that were touched by the chemistry of the storm are processing slowly in their own internal time. There is a wildflower called the wood anemone that grows in old forests, carpeting the floor in early spring with small white flowers. It is a shade-tolerant plant, which means it can grow in the dim light that filters through the canopy before the leaves are fully out. It is also a plant that relies heavily on nitrogen in the soil, not just from lightning, but from the slow decomposition of leaves and wood around it. A patch of wood anemones tells you something about the history of a place. These plants spread very slowly, just a few centimeters per year. A large carpet of wood anemones in a forest might be hundreds of years old. The forest has been providing the right conditions, including enough nitrogen, for all that time. When you see a wild flower, you're not just seeing a flower. You are seeing the accumulated result of years of weather, soil chemistry, microbial work, and patient waiting. We spend so much time thinking about things that happened quickly: news, messages, the speed of modern life. There is something restoring about spending time with the slow things, the things that take years and decades to unfold. The wood anemone has been growing there a few centimeters at a time for longer than any person alive can remember. That is its own kind of extraordinary. Let's talk about thunder itself for a moment. We tend to think of thunder as the sound of lightning, which it is, but it is worth understanding the sequence because it is beautiful. The lightning comes first. It heats the air along its path so rapidly that the air expands faster than the speed of sound. That expansion is the thunder, a shock wave rippling outward from the bolt in all directions. If lightning is nearby, the thunder arrives almost simultaneously, a sharp crack that you feel more than hear. If the lightning is farther away, The thunder rolls in later, a low, slow rumble that seems to come from somewhere vast, somewhere in the distance. People used to count the seconds between the flash and the thunder to estimate how far away the storm was. 5 seconds per mile, the old rule said. So, if you counted to 10, the storm was about 2 miles away. Sitting safely inside, watching the sky, this counting game was a kind of comfort, a way to locate yourself in relation to the weather, to know where you stood. The thunder you hear is the echo of nitrogen being freed. That dramatic rolling sound is the same physics as the gift the rain will bring to the meadow. It is difficult to hear thunder again, knowing this, without feeling some small piece of wonder alongside it. The sound rolls over the fields and the forests and the lakes, and everywhere it passes, the storm has already done its work, leaving behind, in the quiet that follows, a little more nourishment than was there before. We would love to hear your thoughts on tonight's story. If it has helped you relax, or if there is a nature topic you'd like to dream your way through, please leave a comment. This channel grows very much like the wood anemone, one small step at a time. Somewhere in a tropical rainforest, it is raining right now. Rainforests receive extraordinary amounts of rain. Some areas see more than 3 meters of it per year. They also experience frequent thunderstorms, especially in the afternoon, when the heat of the day creates dramatic convective weather, the air rising fast and the clouds building tall and electric. In these forests, the nitrogen cycle is extraordinarily fast. Plants grow quickly, leaves fall quickly, bacteria break things down quickly, and the chemistry of the soil turns over at a pace that would astonish a gardener from a cooler climate. Lightning-fixed nitrogen arrives in pulses with the afternoon storms and is absorbed and used within days or weeks. The trees in tropical forests grow so quickly and so densely that they create their own weather, releasing water vapor through their leaves in a process called transpiration, which contributes to the formation of the very clouds that eventually rain on them. A tropical forest is, in a sense, making some of its own rain, and the animals of the rainforest are part of this chemistry too. Insects eat leaves, birds eat insects. Everything returns to the soil eventually. The nitrogen fixed by lightning in a tropical storm might, within a single season, pass through a dozen different living things: a leaf, a caterpillar, a tree frog, a bird, a fungus, before returning to the soil to be absorbed by roots again. This is one of the reasons why deforestation is so damaging, not just because it removes the trees, but because it breaks these cycles. The nitrogen can no longer circulate in its usual way. The soil, without the trees and the roots and the fungi and the falling leaves, becomes thin and pale and struggles to support new growth. The forest is a community. Every part needs the others, and lightning coming from far above is one of the quiet threads that holds it all together. Let us spend a little time now with the quiet hours before dawn. This is when dew forms. As the night air cools, moisture condenses onto the surfaces of leaves and grass and spider webs, coating everything in tiny droplets. Dew is most beautiful just before the light changes, a moment when everything is still dark, but the shapes of things are beginning to return. Dew, like rain, can carry nitrogen, not as much as a proper rainstorm, but measurably. On summer nights, after electrical storms, dew forming on grass has been found to contain higher levels of nitrogen compounds. The grass absorbs what it can through its leaves as well as its roots. Grasses are particularly good at this. They cover vast portions of the earth, savannas, prairies, steppes, meadows, the lawns of gardens, and they are quietly efficient in their use of nutrients. They have been shaped by millions of years of grazing and drought and fire and storm into something very resilient. In the morning, when the light first touches a dewy meadow and you can see it from a distance, the whole surface seems to glow and shimmer. Each tiny drop of dew is catching the light. And somewhere within those drops, at the microscopic level, the chemistry continues. There is no part of the natural world where nothing is happening. Even the most still-looking surface, at its own scale, is in constant quiet motion. Molecules moving, ions being exchanged, cells doing what cells do, still and moving at the same time, like breathing. You are breathing right now, slowly, we hope, in and out. And everything outside, the meadow and the forest and the sleeping garden, is doing the same, exchanging gases, releasing and absorbing in a rhythm that has no beginning and no end. There is a playlist of other sleepy nature stories waiting for you whenever you're ready. Tonight, we have lightning and soil. Tomorrow there might be rivers or lichen, or the deep and gentle world of the ocean floor. Check the description when you wake. We should talk about a plant called clover one more time, because it deserves more attention than we usually give it. Clover is a common thing, the kind of plant that children pick in summer looking for four-leaf versions, the kind that bees love, the kind that most people walk past without particular notice. But clover is, from a nitrogen perspective, one of the most important plants in the world. As we mentioned earlier, clover's roots are home to nitrogen-fixing bacteria. These bacteria live in small nodules, little round swellings on the roots that you would barely notice if you pulled up a clover plant and looked. Inside those nodules, the bacteria are doing continuously what lightning does in an instant, converting nitrogen into a form that can be used. Farmers have known about this for centuries, even without understanding the chemistry. Rotating crops, growing clover or other legumes in a field one season, then a different crop the next, was one of the oldest agricultural techniques in the world. The clover would fix nitrogen into the soil, and the following year's crop would benefit from it. This is also why clover is so important to bees. Bees gather nectar from clover flowers, and in doing so, they pollinate the flowers, which produces seeds, which grows more clover, which fixes more nitrogen. The whole system feeds itself. On a summer afternoon, in a meadow where clover is growing, you can often hear the bees before you see them. A low, continuous hum just above the grass. That hum is the sound of a relationship that has been evolving for millions of years, between insects and flowers, between flowers and bacteria, between bacteria and the chemistry of the soil. Everything connected, everything slow, everything quietly sufficient. We are coming close to the end of our night walk through the storm and the soil. But let us pause here in the last deep hour before sleep and take one more look at the sky. Lightning strikes the earth roughly 40 to 50 times per second globally. In a single year, that amounts to somewhere around 1.5 billion lightning strikes, each one briefly heating the air, each one cracking open those bonds between nitrogen atoms, each one sending a tiny, invisible gift dissolving into the rain. Across a year, globally, lightning is responsible for fixing somewhere between 5 and 10 million tons of nitrogen into the soil. That sounds like a large number, and it is. But it is modest compared to what the nitrogen-fixing bacteria in the soil, those tiny specialists, achieve on their own, closer to 200 million tons per year. Lightning is not the only way. It is one way, a dramatic, ancient, visible way. The sky writing its chemistry across the clouds and delivering it in the rain. And all of this, the lightning and the bacteria and the rain and the roots and the fungi and the worms and the leaves and the dew, all of it is working together continuously to keep the green world green. You do not have to do anything for this to continue. It does not need your help. It is simply happening right now while you rest. Outside, wherever you are, the soil is breathing and processing and holding and releasing. Seeds are waiting in the dark. Roots are reaching. Somewhere above your roof, the atmosphere is vast and full of nitrogen, waiting for the next storm to come and crack some of it open. The world is very good at what it does. There is nothing left to do now but be still. The storm has passed. The lightning has done its work. The rain has carried its gift into the ground, through the layers, into the roots and the seeds and the tangled dark of the soil. Somewhere, a small plant has received something it needed. Somewhere, a seed has shifted just barely toward beginning. You are part of this same world. The nitrogen in your cells, in the proteins that move and the membranes that hold you together, has been fixed and dissolved and absorbed and eaten and breathed and fixed again, over and over, through time so long it has no clear edge. You are old and young at the same time. You are temporary and made of ancient things. The meadow outside is quiet. The forest is dripping. The soil holds its warmth. The worms rest in their tunnels. The seeds sleep in their coats. The fungi stretch their threads between the particles of earth, slow and purposeful and unaware. And you are somewhere warm, somewhere soft, with nothing that needs doing and nowhere that needs reaching. Let the weight of your body be fully held. Let your breathing slow to the pace of a sleeping meadow. Let your thoughts become less distinct, the way the edges of fields disappear into fog in the early morning. Here are 10 more parts, continuing seamlessly from part 15, written as a natural extension of the same story, same tone, same pace. There is a place in the world where lightning strikes more than almost anywhere else on Earth. Near the shore of Lake Maracaibo in Venezuela, where warm, humid air rises from the water and meets the cool air tumbling down from the surrounding mountains, a storm forms almost every night. It has been happening for as long as anyone in the region can remember. Indigenous peoples who lived there gave it a name, Catatumbo lightning, named after the river nearby. Sailors used to navigate by it. They called it the Lighthouse of Maracaibo. On a typical night, this storm might produce as many as 28,000 lightning bolts, night after night, in the same place, over the same lake, for much of the year. The land and water around it has been receiving this extraordinary nitrogen gift over and over for centuries. The lake and the forests and the grasslands of the surrounding region have been bathed in lightning-fixed nitrogen with a consistency that most places on Earth never experience. Scientists who study this phenomenon have noted the unusual richness of the ecosystem around the lake. The wetlands there are extraordinarily productive, full of birds, fish, aquatic plants, and insects in numbers that reflect what happens when a piece of land receives, again and again, more than its usual share of the sky's chemistry. It is a strange and beautiful idea that a place could be made richer by its storms, that the most dramatic and electrical nights could be the very ones contributing most to the gentle business of growth. Most of us experience lightning as something occasional and unpredictable, a summer surprise, a reason to step indoors. But at Lake Maracaibo, the lightning is as regular as the tides. The ecosystem has shaped itself around it. The roots and the bacteria and the fungi have come to expect it. The night closes in and the storm begins again. And the same chemistry that has been happening since the earliest days of the earth begins once more in the Venezuelan dark. Let us visit a place that is almost the opposite of a tropical wetland, a high alpine meadow above the tree line, where the air is thin and cold and the growing season is so short. It lasts only 2 or 3 months before the snow returns. Here the plants are small and low, pressed close to the ground, where it is fractionally warmer, where the wind is slightly less. Tiny flowers, no taller than your thumbnail, in yellows and purples and the palest pink. These plants have solved the problem of the short season by being extraordinarily efficient. They do not waste energy on height or dramatic displays. They concentrate everything into the essentials: a small, tight rosette of leaves, a quick flower, a seed matured before September comes. And they rely on every bit of nitrogen they can get. At altitude, the nitrogen cycle moves slowly. The cold slows the bacteria. The thin, rocky soil holds fewer organisms of every kind. Lightning does still occur at altitude. In fact, alpine areas experience intense thunderstorms, and the proximity to the clouds means lightning strikes can be more frequent than in some lowland areas. But the thin, fast-draining soil cannot hold nitrogen-rich water for long. It passes through quickly. The plants here have learned to catch what they can quickly. Some alpine plants have evolved to absorb nitrogen directly through their leaves, not just through their roots, a strategy that makes sense when every drop of rain that touches a leaf carries a small amount of dissolved nitrate from the sky. After a thunderstorm in an alpine meadow, the whole surface of the ground gleams for a day or two. Then the sky turns deep blue again, the kind of blue that is only possible at altitude, and the small flowers stand in their tight clusters and do their work in the cold, clear air. There is something deeply calming about the image of these tiny flowers, so small, so determined, so completely unbothered by the bigness of the mountains around them. You do not need to be the tallest thing in order to grow. We have talked mostly about plants and soil and rain, but let us spend a little time now with the insects, because they are part of this story too. Butterflies are among the most sensitive indicators of a healthy ecosystem. They need specific plants to lay their eggs on, specific flowers for nectar, specific soil conditions. When a meadow is doing well, when the nitrogen is balanced, the soil is rich, the plants are varied, the butterflies are usually there. After summer rainstorms, if you have ever walked through a meadow and found yourself surrounded by butterflies moving through the wet grass, You have experienced this connection firsthand. The storm brought nitrogen. The plants responded over time. The flowers were more plentiful or more nourishing. The butterflies followed. It is a chain that stretches from the sky to the storm, to the rain, to the roots, to the flower, to the wing. Each link barely visible from the ones far from it, but connected through this long, quiet chemistry. Moths, which are less celebrated than butterflies, but no less beautiful, do much of the same work at night. While most of us sleep, moths move through meadows and forests in the dark, visiting flowers that have evolved specifically to attract them. White flowers, pale and luminous in the moonlight, open only after dark, with scents released specifically in the night air to reach moth antennae. The meadow at midnight is as busy as the meadow at noon in its own quiet way, and the nitrogen fixed by last week's lightning is present in the nectar those moths are drinking, passed up through roots and stems and petals to this moment. This moth, this soft hovering above a pale flower in the dark. We are so often unaware of how much is happening. One of the most extraordinary things about nitrogen is how it moves through time as well as space. Consider an ancient tree, a yew perhaps, growing in a churchyard in England. Yews are among the longest-lived things in the world. Some of the oldest specimens are thought to be 4,000 or 5,000 years old, possibly more. They were old when the churches were built around them. The nitrogen in the wood and bark and needles of a very old yew has been accumulating and cycling for millennia. Some of it was fixed by lightning strikes that happened before any human memory. The tree has absorbed it through its roots, incorporated it into its cells, shed needles that broke down and returned nitrogen to the soil, which was then reabsorbed by the tree's own roots. The tree has been in a long, slow conversation with the soil and the sky for thousands of years. There is a kind of deep rest in thinking about this. The tree is not hurrying. It has no appointments. It has been doing the same things, absorbing, growing, shedding, resting through winter, beginning again in spring, for longer than most nations have existed. And every time lightning has struck nearby, for those thousands of years, a little nitrogen has dissolved into the rain and moved through the ground past the yew's roots. The tree may have incorporated atoms that were fixed by lightning in the time of ancient civilizations. Atoms that were, before the lightning, drifting in the air over a world that looked very different from this one. The yew holds time in its rings, each one a year, pressed together as the tree grew. And in the chemistry of those rings, in the nitrogen and carbon and other elements woven into the wood, is the record of weather and soil and all the storms of all the years. Trees are, in their way, libraries. Let your thoughts become slow now, like the growth of a very old tree. One quiet ring at a time. There is something we have not yet mentioned, and it is one of the loveliest parts of this whole story. After a thunderstorm, many people notice a particular smell in the air. It is clean and sharp and green electric, and it fades within an hour or two as the storm moves on. Some people call it the smell of rain. Scientists have a few different names for the compounds responsible. One is petrichor, the scent released when rain falls on dry earth. It comes partly from a compound produced by soil bacteria, which have been waiting in a kind of dormancy for moisture, and which release this aromatic oil when Water activates them. Petrichor is literally the smell of life waking up. Another part of the after-storm scent is ozone, produced when the lightning's energy splits oxygen molecules in the upper atmosphere, some of which then recombine into 3-atom oxygen molecules instead of the usual 2. Ozone has a clean, faintly metallic smell that many people find extraordinarily calming. So, when you step outside after a storm and breathe in that cool, washed air, you are smelling in one breath both the electricity of the sky and the waking of the soil. You are smelling the chemistry of life restarting, the bacteria in the ground, the seeds that might stir, the nitrogen dissolving in the last of the rain. All of it is present in that smell. The nose knows it before the mind does. If you can remember that smell right now, bring it into your mind, that cool, green, electric scent, the world after rain. Let it move through your imagining body like a slow breath. You are safe. You are warm. And somewhere outside, the earth smells like this and everything is beginning again. Let us drift now to a place where the storm is past, but the water is still moving. A stream in a forest after rain. It is higher than usual, running faster, a little cloudy, with the soil it has picked up from the banks. It moves over stones and around roots, finding the easiest path downward, as water always does. On the surface, small bubbles form and disappear. A leaf rides the current for a moment, then catches on a twig and stays. The stream is carrying nitrogen too. Some of the lightning-fixed nitrogen that fell with the rain onto the forest floor has dissolved into the water running off the slope and joined the stream. It will travel downstream through meadows and lowland forests until eventually it reaches a river and then perhaps a lake or the sea. In a lake, that dissolved nitrogen becomes food for algae and aquatic plants. In small, balanced amounts, it is essential. The lake depends on it, just as the meadow does. The fish that eat the algae, the birds that eat the fish, the trees along the lakeshore that are visited by those birds, all of them benefit in their own indirect way from the lightning that struck somewhere uphill days or weeks ago. Nothing is wasted. Everything is somewhere in the cycle. The stream catches the last of the evening light, a shimmer moving downstream, a brightness that follows the current. In a few hours, it will be dark here, and the stream will make its sound in the dark, unhurried, turning over the same stones it has been turning for years. Water moving at night is one of the most peaceful sounds in the world. If you can hear water nearby, rain on a window, the quiet hum of pipes, let that sound carry you now. Let it be the sound of things moving in the right direction. There is a concept in ecology called the cascade effect, and it is very relevant to what we have been exploring tonight. A cascade means that one thing changes, and that change causes another change, which causes another, rippling outward through the system in ways that can be traced but not always predicted. Lightning fixing nitrogen is the beginning of a cascade, a gentle one, a slow one, but real. The nitrogen reaches the soil. The plants grow a little fuller, a little greener. More leaves means more shade, which means the soil beneath the plants holds moisture longer. Longer moisture means bacteria can work for more of the year. More bacterial activity means more nutrients cycling through the soil. More nutrients means more plants can grow. More plants means more insects. More insects means more birds. And further out, more birds means more seeds carried to new places. More seeds in new places means more plants in places that were bare before. More plants in new places means more roots, which means the soil in those new places starts to develop, to deepen, to become capable of holding more life. A lightning bolt over a meadow in spring, the cascade of which is still, slowly and invisibly, unfolding years later in a patch of woodland on a hillside nearby. We rarely get to see things at this scale in our own lives. We are too small and too fast-moving. But it is comforting somehow to know that these slow cascades are always happening around us, that the world is always becoming something, always moving toward more complexity and more connection, even in the spaces we cannot see. The world is doing well at the scale it knows best. We have been traveling through this story for a long time now, and perhaps you are very nearly asleep. That is good. That is exactly right. But before you go completely, let us rest for a moment with one of the smallest things in this whole story, a nitrogen atom. It is so small it cannot be seen by any microscope yet invented. It has no color, no smell, no weight you could feel in your hand. And yet, everything we have talked about tonight has been, at its core, about this tiny thing and its journey. It began in the atmosphere, floating there, bonded to another atom just like itself, completely unavailable for life. Then came the lightning, a moment of extraordinary heat lasting less than a second. And in that moment, the atom was freed. It combined with oxygen. It dissolved in water. It fell with the rain. It moved through soil, past stones and roots and worms and fungal threads. It was absorbed by a root hair, pulled up through the stem, incorporated into a leaf. It became part of chlorophyll. It helped capture sunlight and turn it into sugar. Perhaps it was eaten by a caterpillar. Perhaps it became part of a wing. Perhaps the bird that ate the caterpillar eventually released it back to the soil. Perhaps it was absorbed by another root and began again. Or perhaps it is still in a tree somewhere, inside a ring of wood, laid down in a summer when lightning struck close by and the rain that followed was generous and the soil responded with quiet gratitude. One small atom, an unimaginably long journey through sky and rain and root and leaf and wing and soil and back again. You are made of journeys like this one. The night is deep now. If there is a window near you, the sky outside is either dark and quiet, or perhaps, if you're lucky, there is a distant storm somewhere, a flicker at the edges of the clouds, too far away for sound. Lightning seen from a great distance is one of the most peaceful things in the world. No sound, just a slow brightening at the horizon, a bloom of light in a cloud, gone before you are sure you saw it. And now you know what is happening out there in that quiet flash. The air is cracking open. Nitrogen is being freed. In a few hours, rain will carry it down. By morning, the meadows and forests beneath that distant storm will have received something they needed. The world takes care of itself tonight, as it has always done. You have followed this story from the very first charge building in a cloud, all the way down into the dark soil, through the roots and the seeds and the ancient trees and the butterflies and the mountain flowers and the late-night moths. You have traveled further than you might have thought without moving at all. That is the gift of a slow story. It carries you somewhere while you stay completely still. Your body is heavy now, we hope. You're breathing slow. Your thoughts not quite thoughts anymore, but something softer. Images without edges, feelings without words. The soil is warm. The roots are reaching. The seeds are still. The bacteria work in the dark as they have worked since the beginning. And you can stop working now. Let the night hold you the way soil holds a seed, gently, completely, and without asking anything in return. This is the very last part, and it is the quietest. We do not want to fill it with more facts, or more images, or more journeys across meadows and forests. We want to leave a space here, a soft, wide space, like the pause between one breath and the next. The lightning has done its work, the rain has fallen, the nitrogen has found its way, and somewhere in the dark and the warmth of the soil, something has shifted so slightly, so slowly, that no one will notice for weeks. A root has absorbed something it needed. A seed has come a fraction closer to waking. A fungal thread has passed a small gift from one tree to another. The world is in the business of becoming, and it does not need any light to do it. It does not need applause or attention or anyone to watch. It just does it. In the dark, in the quiet, one slow molecule at a time. And you are part of this same world. You are breathing it in and out. You are warm with the same chemistry. You are resting in the same long story. There is nowhere you need to be, nothing you need to do. The soil knows what to do with rain. The seed knows what to do with nitrogen. And your body, wise and ancient in its own way, knows what to do with night. Close your eyes now, if they are not already closed. Let everything be still. The storm has passed. The earth is resting. And so are you. Sleep well and gently. We will be here when you wake. Thank you so much for spending this long, quiet evening with the Sleepy Nature channel. If this story helped you drift off, a like means the world to us. And if you'd like to share a thought in the comments, we would love to read it. The playlist is always waiting for your next sleepy night. Here are 10 more parts continuing the story seamlessly in the same soft tone and pace. There is a particular kind of silence that exists only in the hour just before dawn. It is different from the silence of midnight, which still holds the weight of the day just past. The silence before dawn is lighter somehow, expectant, but not anxious. The darkness is beginning to thin at its edges, though you would not quite call it light yet. The stars are still visible, but faintly. The air has reached its coolest point. And in this hour underground, the soil is as active as it has been all night. The darkness makes no difference to what happens below the surface. Bacteria do not need light. Fungi do not need light. Roots grow in the dark as readily as they would in any other condition. The nitrogen that arrived with yesterday's storm has been moving through the soil all night long, slowly, incrementally, finding its way into spaces between particles of clay and sand, being taken up by root hairs so small they are nearly invisible even under a lens. Root hairs are extraordinary things. They are single cells extended into a long, thin tube reaching out from the main root into the surrounding soil. Each one is in contact with the soil at a scale too small to imagine easily, touching individual particles of mineral, individual droplets of soil water. Through these single cells, the plant is tasting the world around it, drawing in what it needs. A single rye plant if you were to measure all of its root hairs end to end, would stretch for hundreds of kilometers of living surface in contact with the soil, all day and all night, absorbing water and minerals and the nitrogen that the rain delivered. The plant above ground, the part we see, is only the smallest part of the story. Most of the plant's life happens where we cannot see it, in the dark, in the slow, in the quiet work of drawing in what is needed from the world below. This is, perhaps, a thought worth sitting with in the hour before dawn. So much of what sustains us is invisible, happening in the background, without our awareness or assistance. The body breathing while we sleep, the soil cycling while we rest, the roots reaching in the dark. Let us talk about lichen for a moment, because lichen deserves much more attention than it usually receives. Lichen grows on rocks, on tree bark, on old wooden fences, on the surfaces of gravestones worn soft by decades of rain. It is one of the most patient things in the world. Some lichen species grow only a millimeter per year. Some are thought to be thousands of years old. Some lichen found in Arctic regions may be the oldest living organisms on the surface of the earth. Lichen is not a single organism. It is two, sometimes three, living together so closely that they function as one. A fungus provides structure and shelter. An alga or a cyanobacterium lives inside that structure and performs photosynthesis. The fungus benefits from the sugars the alga produces. The alga benefits from the protection the fungus provides. And here is where it connects to our story. Some of the cyanobacteria that live within lichen are nitrogen fixers. They can take nitrogen from the air, not from lightning, not from rain, but directly from the atmosphere, and convert it into usable forms. Lichen growing on rocks in a bare landscape can, over time, begin to enrich the surface it lives on, making it more hospitable for the mosses and small plants that come after. Lichen is a pioneer. It goes where nothing else can go. Bare stone, weathered wood, the near barren surface of a newly exposed rock face, and it begins the slow work of making that place ready for life. When lightning-fixed nitrogen eventually reaches a rocky hillside in rain, it finds, in many places, lichen already there, already working, already enriching, already preparing the ground for what comes next. The world is always preparing. Something is always getting ready. Even the most barren-looking surface has already begun. Rain falling on the ocean is a different thing from rain falling on soil. The ocean is vast, covering more than 70% of the Earth's surface, and it too receives lightning-fixed nitrogen in rainfall. The nitrates dissolve and sink slowly through the layers of water from the sunlit surface zone down into deeper, darker water below. Near the surface, where light penetrates, tiny organisms called phytoplankton use these nitrogen compounds to grow. Phytoplankton are microscopic, single-celled, or in small chains or clusters, drifting at the mercy of currents. They are so small you cannot see a single one. But there are so many of them that from space, their blooms appear as shifting patterns of blue and green on the ocean's surface. Phytoplankton produce roughly half of all the oxygen in the atmosphere. Every second breath you take was made possible, in part, by these invisible ocean drifters. And they depend, in part, on nitrogen, including nitrogen that came from lightning over the ocean's surface. This is a connection that is very easy to miss. The storm over the mid-Atlantic last week, The lightning that flashed between clouds above open water with no ships and no witnesses deposited nitrogen into the rain that fell on the ocean below. That nitrogen fed phytoplankton. Those phytoplankton released oxygen. That oxygen joined the atmosphere, and perhaps weeks later, you breathed it. The world's systems are connected in ways that span continents and oceans and months of time. The breath you are drawing right now is partly made of ancient lightning, dissolved in ancient rain, absorbed by ancient sea. Breathe slowly. Feel the weight of that gently, without trying to fully grasp it. Some things are too large to hold. They can only be felt. There is a wildflower in European meadows called ragged robin, and it is exactly as lovely as its name suggests. Its petals are deeply cut into thin strips so that each flower looks softly disheveled, like something that has been caught in a gentle breeze for a very long time. It grows in damp meadows and along stream banks, in places where the soil stays moist and the nitrogen cycle is active. It flowers in early summer in shades of pink so particular they are difficult to describe. Not quite cerise, not quite rose, something in between that catches the light in a way that feels almost surprising. Ragged robin is a plant that is becoming rarer in many parts of the world, as the wet meadows it depends on are drained for agriculture or development. Where it does still grow, it is a sign that something has gone right with a piece of land, that the soil is balanced, the moisture is consistent, the nitrogen is present in the right amounts. The meadow has not been overmanaged or chemically treated. Finding a ragged robin in a meadow is like finding a small piece of evidence that the world is still working the way it should. There are people who spend their lives working to preserve places like this, to maintain the conditions that allow ragged robin and marsh marigold and meadow cranesbill and all the other quietly beautiful flowers of damp meadows to keep existing. They restore wet grasslands. They manage water levels. They remove invasive species with great care and patience. It is slow work, like most important things. But in a restored meadow, after a few years, the flowers return. First the grasses, then the sedges, then, eventually, the ragged robin. The soil remembers. Given the right conditions, it will return to what it knows how to be. Let us visit a storm that is happening right now, somewhere on the other side of the world. It is afternoon there, a hot, humid afternoon, in a place where the rainy season is in full force. The clouds have been building since midday. From the ground, looking up, they are immense, cauliflower white at the top where they catch the sun, blue-gray at their bases where they are heaviest with water. Inside them, ice crystals and water droplets are colliding, building electrical charge, positive charges rising, negative charges sinking, until the difference between the cloud and the ground below is so great that the air itself briefly becomes a conductor. The lightning falls in a branching path, choosing the route of least resistance through the air, each branch splitting and splitting again into smaller filaments. The whole thing lasts less than half a second. The thunder follows a moment later, a sharp crack expanding into a low roll as it travels outward. And in that half second, the nitrogen work is done. Silently, invisibly, in the heated air around the bolt, nitrogen molecules crack apart. The reaction happens and is complete before the thunder even sounds. The rain that follows carries the result downward. In 30 minutes, That nitrogen will be in the soil. In a few days, it will be in a root. In a few weeks, in a leaf. In a few months, perhaps in a fruit that falls from a tree and is eaten by something that will carry the nitrogen further still. Somewhere on the other side of the world, right now, all of this is beginning. You cannot see it. You cannot hear it. You are warm and horizontal and drifting pleasantly. But it is happening, steady and reliable, as it has always been. The world does not stop when we sleep. It simply continues, quietly, in the dark. If you have been enjoying these long, slow journeys into the natural world, you're always welcome to share this channel with someone who might need a little more quiet in their life. The playlist grows slowly and steadily, like a meadow returning to itself. Morning light moves across the earth in a continuous wave, the shadow of night retreating westward as the planet turns, slowly revealing one time zone after another. At the edge of that wave, where darkness meets the first pale gray of dawn, the birds begin, not all at once. There is an order to it, a sequence that ornithologists have mapped and studied. The blackbird often begins first, a single, unhurried song, rich and liquid, phrasing and rephrasing the same idea from a high branch while everything else is still quiet. Then the robin. Then, as the light increases, the other voices join, one by one, until the air is full of overlapping sound. This is what is known as the dawn chorus. It happens every morning, all over the world, wherever there are birds and trees in the returning light. The birds singing in the dawn chorus are, many of them, defending territories. They are also, in a very direct way, products of the soil. The insects they ate all summer, the caterpillars, the beetles, the aphids, were themselves products of the plants. And the plants were built from nitrogen, which came from the soil, which received it from the rain, which brought it down from the sky, where lightning cracked it loose. The song of a blackbird in the morning is, in a long and indirect chain of reasoning, made partly of lightning. This is the kind of thought that the drowsy mind finds pleasing. It does not need to be analyzed. It can simply be felt. The pleasant looseness of knowing that everything is connected, that nothing stands alone, that the song in the tree and the storm last Tuesday are part of the same long story. Let the idea drift. Let it become less precise and more feeling. That is a good direction to travel in at this hour. There is a type of cloud called a cumulonimbus. It is the cloud of thunderstorms, the tallest, the most dramatic, the most electrically charged. A fully developed cumulonimbus can reach from a few hundred meters above the ground all the way up to 15 or 16 kilometers into the atmosphere. If you stood one beside a mountain, the cloud might be twice the mountain's height. Inside it, air rises at speeds of 100 kilometers per hour. Hailstones form and are tossed upward and grow heavier and fall and rise again before they are finally heavy enough to reach the ground. And yet, from a distance, at the right moment, a cumulonimbus is one of the most beautiful things in the sky. Seen from an aeroplane, flying past one in clear air, it looks like a sculpture. The top is flattened by the upper winds into a shape called the anvil, a broad, flat spreading of cloud at the boundary where the rising air can go no higher. In the evening light, these anvils catch the sun long after the ground below is in shadow. They glow orange and pink and gold. They look from the right angle like something deliberate, like something a very patient artist has been working on all afternoon. Inside that beautiful, glowing sculpture, lightning is moving. Nitrogen is being freed. The chemistry of life is happening in the charged and icy air at the top of the troposphere. Beauty and purpose occupying the same space, neither one diminishing the other. This is true of many things in the natural world. The spider's web is beautiful and functional. The honeycomb is beautiful and structural. The cumulonimbus is beautiful and chemical. The world does not choose between being useful and being lovely. It simply is both, without effort, without intention, as a matter of course. You can let that be enough for now. We have talked about many things that lightning gives the soil. But let us spend a little time now with what the soil gives back. The earth releases gases too. Carbon dioxide, produced by the breathing of billions of soil organisms. Methane in certain waterlogged conditions. Water vapor rising from moist soil surfaces into the air. Volatile organic compounds produced by plants and bacteria rising invisibly through the day. And nitrogen gas itself, because the nitrogen cycle does not only run in one direction. As well as nitrogen being fixed into the soil from the atmosphere, nitrogen also returns from the soil to the atmosphere. Denitrifying bacteria, a different group of specialists from the nitrogen fixers, take nitrogen compounds in the soil and convert them back into nitrogen gas, releasing it upward. In a healthy ecosystem, these two processes, fixation and denitrification, balance each other. Nitrogen flows in from the sky via lightning and bacteria. Nitrogen flows out from the soil via other bacteria back to the sky. The atmosphere maintains its composition. The soil maintains its balance. This is a cycle that has been running continuously for billions of years without anyone keeping score. The bacteria do not coordinate. The lightning does not plan. And yet, the result is a balance so precise that the atmosphere we breathe today is almost chemically identical to the atmosphere that existed tens of millions of years ago. Something very large is in balance. Something very old is still working. We spend a great deal of time worrying about balance in our lives, in our diets, in our time and energy. And some of that worry is useful, but it is also restoring to remember that balance at the largest scales is not something that has to be achieved by effort. It is something that emerges naturally from systems that have had enough time. You have had a long day. Your own balance will come with rest. Let the night help you find it. There is a plant called sundew that lives in bogs and wet heathlands, where the soil is so acidic and poor in nutrients that almost nothing else can survive. Sundew has solved the problem of nitrogen-poor soil in a remarkable way. Instead of waiting for lightning or bacteria to deliver nitrogen from below, it catches it from above. Its leaves are covered in long, glistening hairs, each one tipped with a tiny droplet of sticky fluid that catches the light like a dewdrop. An insect landing on a sundew leaf becomes trapped in this stickiness. The leaf slowly curls around it, very slowly over the course of hours, and digests it. The sundew is a carnivorous plant in the gentlest possible sense. It is not aggressive or dramatic. It simply waits, glistening in the bog, and the nitrogen it cannot get from the soil. It gets from the small creatures that are drawn to the light, catching in its drops. There are many carnivorous plants, all of them living in places where soil nitrogen is too low to support normal growth. pitcher plants with their deep fluid-filled tubes, Venus flytraps with their hinged, tooth-edged leaves, bladderworts, which are aquatic and trap tiny water creatures in small bladders that snap open and shut faster than almost any movement in the plant kingdom. Each one is an answer to the same question. How does a plant get nitrogen when the soil cannot provide it? And each answer is different, creative, and in its own way, beautiful. Life finds a way to be ingenious. It does not accept the limitation as final. It finds another route. The sundew in its bog, waiting with its glistening hairs, is as patient as the yew in its churchyard, as quiet as the root hair reaching through the dark, as connected to the whole long story as the lightning bolt that cracked the sky open 3 weeks ago and began in its brief and brilliant moment. This whole gentle chain of events, this is where we rest. Not because the story has ended. The story does not end. The nitrogen cycle has no ending. The lightning will strike again tomorrow, and next week, and in 100 years, and the rain will carry the same gift to the same waiting soil, and the roots will reach, and the seeds will stir, and the birds will sing in the morning, and the fungi will thread through the dark, and the lichen will grow its millimeter for the year, and the sundew will wait in its bog with its glistening patience. It continues, all of it, without ceasing. But you can stop here and let it continue without you for a while. That is what sleep is, a trusting pause, a moment of releasing the thread. The world will pick it back up. It always does. You have traveled a long way tonight without moving. You have been inside clouds and inside soil and inside the cells of roots too small to see. You have been in Venezuelan wetlands and alpine meadows and the canopy of ancient pine forests and the cold, quiet water beneath the surface of a northern lake. And now you are here. Wherever here is, a bed, a sofa, a quiet room, something warm around you, gravity doing its patient work. Outside, somewhere, a storm is ending. The last of the rain is touching the surface of a meadow. The last drops are carrying nitrogen into the last inches of soil before the night finishes its work. And a seed, somewhere, is a little closer to waking. You do not need to see it happen. You do not need to watch. Just know that it is happening, out there in the quiet and the dark, and let that be the last thought, warm and green and slow, as you find your way into sleep. The earth is tending itself. You are tended to. Rest now, completely and without worry. We will be here, quiet and waiting, whenever you return. Thank you for another long and gentle evening with the Sleepy Nature Channel. If this story has helped you find some peace, a like and a comment are always deeply appreciated. And if you know someone who struggles to sleep, perhaps share this with them. The playlist holds many more quiet journeys, sweet dreams, and we will see you next time.